Okay, so Codeforces Round 939, right, div 2. In this one I'm going to be explaining A, B and C problems, both of these, because all the three of these, because these are the three that I could understand. I mean, I only solved A and B in contest, but C was easy. So okay, we'll start with A first. Thing is, they gave us, first things first is an array A and an array Q. Okay, now in this array A, let's take it as the example itself. What is it? What was it? 3, 5, right? 3, 5. Now this is the array of the number of participants that will be removed from the team. For example, like they gave us like A, B, C, D. For example, we have participants like this. Now in this game, people, for each and every turn, people will be removed. The third and the fifth person will be removed from the team. If the fifth person in this case is not there, we'll add it A, B, C, D, E. So in this case, for the first iteration, for the first one, we'll remove C and E. So it will be A, B and D. Now after this, we'll again remove third, which is D, but there is no fifth. So we'll move on. And after this, we'll get A and B. And from A and B, we can't remove anything. We can't remove third and fifth because there is no third and fifth. So the remaining players are the winners. So in this case, A determines like what are all the places that should be, from which the player should be removed for each and every place on single turn. And Q in this case determines the number of players that are present. For example, in this case, you can take 1, 5, 6. Okay, so in the first Q, which means that in the first game, there is only one person, A. In this case, 3 and 5 won't do anything, and since there is nobody was removed from the team, which is only consisting of one person, the number of winners are 1. And that similarly you have to calculate for all of these. So for this, the thing is simple. If you take, for example, sum 3, 5, 8, 9, 10, 20, it said that it will be in increasing order. So in this case, let's take A, B, C, D, E. Okay, F. We'll take F. Now look at this. Third one, first one, we'll look at this thing incrementally. Third was removed, and then fifth was removed, and that's it. And then the rest of these won't be affected at all. So then we'll be left with A, B, D, F, right? Now again, we'll remove third one, and we'll remove nothing else is there, so we'll go on to the next one. Now if you keep noticing something, these letters or these players are not being affected. It's because in this case, we'll remove the players starting from this index and ending from this index. So any player whose index starts from 3 and ends till 20, if it even ends till 20, has a chance of being removed and will be removed at some point, except for the players whose index is less than 3. In this case, the index is 1 and 2 for A and B. So if you keep doing this thing, at the end, third will be removed again, A, B and F will be removed, and we'll be left with A and B because there is no third one. So the final players will be 2. So the answer for this is simply whatever is the small. First things first. Another thing is, if the player Q is A, or in this case Q is 1, right, and this is A, then in that case 1 is there. So A is the answer, right? A is the only player there, and 1 is the answer. So what is the conclusion from this is, first things first, if the value of Q is less than or less than A of 0, the first value of A, if Q of I is less than this, then we'll print Q of I, because that will be the answer. If Q of I is greater than A or 0 or equals to 2, then if Q of I is greater than or equals to A of 0, then we'll print A of 0 minus 1. See, minus 1 because in this case, if third one will always be removed, then any index before third one will be there. So the 2, if the index is 3, then only every element before 3 will be there, which is 1 and 2. So In this case, if the a of 0 is 5, then every element before 5, which is first 4 elements. So a of 0, the smallest one, minus 1, will be the number of elements that will be present. So this is the only condition. The first condition is q of I. If it's is less than a of 0, then print q of I. If q of I is greater than or equals to a of 0, then print a of 0 minus 1. So this concludes A. Now let's talk about B. Okay. In B, if you look at it, I think the problem was they'll be given us cards, right? So we'll be given 2n cards. Let's take you are a player, you versus a girl. I don't know what his name is. So they'll be given 2n cards of each counted from 1 to n. So 1 to n. So for example, if n is 4, then 1, 2, 3, 4, 1, 2, 3, 4. These are the cards that will be there. 1 to n for each. Okay. After this, you will be shuffled the cards and given a random set. You don't know what that set is. You'll be given n cards. You'll be given n cards, and the girl will also be given n cards. Now, what the rules here is, what the game will happen is, how the game will play out is, so first things first, your turn first. You will start first, and what you'll do is you will place a card down on the table. After that, from this point on, if the girl has that card, she'll get a point increment 1, and she'll place that card on the table. And if you remove it, then after that, if you remove a card and you have the point already, if you have the card is already there, you have the card, then you also get a point. So basically, let's take an example. For example, 1, 2, 3, 3, 1, 2, 4, 4. Okay. You are given the first n cards, the n cards and this n cards. If you add these, you'll get this only at the end. This is a subset of these two. So first, imagine you place 3. Okay, in the first round you place 3. So 3 is there. Now this is the card. What do you say? These are the cards you have after this. Then this girl plays, she doesn't have 3, right? You have the other 3. So for example, she will place 4. Okay, she will place 3 and 4. So it will become 1, 2, 4. Again, you will place 3. Now you have the 3 is on the table, right? 3 is on the table and you place 3. So you will place 3. First things first. And you also get a point plus 1. Okay. Now what will happen with the girl is she will also place a card 4, and she will also get a point. It will be 1, 2. Now after this, what will happen? Let's say you put 2 again. Now she will put 2 and since 2 is on the table, she'll get a point. So 1 and 1. Now you'll put 1 and she'll put 1. Now since 1 is on the table, she'll get plus 1. So with this itself, I think you understood the answer, but let me explain. So the thing is, if the number is already on the table and you have that, if you're about to place that card, then you'll get 1 point. So the thing is, how many points, for example, if they gave a particular n, what will be the number of points that you can get if you play optimally? See, the thing is, here you have been screwed from the beginning because you are the one who's supposed to play it first. See, the thing is, in this game, in this particular game, whoever starts playing first loses. That's it. I mean, has a lesser chance of winning. It's either you will tie with her or you will lose. She'll get more points. That will happen all the time. So now look at this. That will happen because, see, if you take just one card, okay, you first place a card. So the table is empty. Now she knows that number. Okay, you can see the table, you can see what the numbers are. So she knows, okay, 1 is on the table. She'll just check where 1 is and she'll place it. Now imagine if it's something like 1, 1 and 2, 2. Okay, what if in this case? In this case, you'll place 1 and she won't have 1, so she will place 2. And after that, you'll place 1, you'll get 1 point. She'll place 2, she'll get 1 point. So at the end, it's either a tie between 2 or she'll get 1. So now in this case, you don't want to check who's going to win or something, because if we say who's going to win, it's always going to be the girl. If we check that ties also win. So the thing is, we need to calculate the points we are getting. So in this case, you will get points only if there are multiple numbers. You have like multiple of the same numbers, only then you'll get it. In this case, you can only have two numbers, right? And since there are only 1 to n of two combinations, so 1 comma 1 will be the only possible. You won't get 1 comma 1 comma 1 comma 1. That won't be possible. So let's take it like this: 1 comma 2 comma 3 comma 4. If you are given this thing, I mean, in the test case, it will be only given this, but you can, I mean, you can guess, right? If this is 2n and this is a thing, that so for her, it will be this. You can understand that based on this. So in this case, if you have this, you are losing. You will get 0 points because you'll place it, she'll place, she'll get 1 point. You'll place it, you won't get any points. You'll place this, she won't place it because if she's playing optimally, she'll place whatever card you have placed to get the number. And after this, she'll again place 3, then you place 2, then she'll place 2, then you'll place 1, she'll place 1. You won't get any points. We don't care about whether she gets points or not. So in this case, you'll only get points if you have multiple of the same numbers, which means that if you have 2 comma 2 comma 3 comma 3 and 1 comma 1 comma 4 comma 4, in this case she'll also get points, but you will get 2 points because first you'll place 3 2 times and you'll get 1 point from 3, and then you'll place 2 and you'll place 2 again, you'll get 1 point from 2. So basically the thing is, your answer will be the answer will be determined by, if you are given the array of number of cards you are given, the number of times a particular number is repeating will be the count. So for example, in this case, the count of a number repeating 2 times is 2, right? You just go through a for loop, you add a map, and if that map, you keep incrementing the value of that map, and if it's equals to 2, you will increment the answer by 1, and that is it. If you keep doing that, you'll find out the values for which you will win. So if there are 3 comma 3, in this case I told you 3 comma, if in this case there are no similar values, all of them have a count of 1, so the answer will be 0. In this case, the answer will be 1. If it's something like 1 comma 2 comma 4 comma 4, the answer will be 1. So yeah, that's it. This is for B. Now for C, the thing is, I couldn't solve it in the contest because the first things first, I didn't get the idea. But okay, the actual concept is easy. So first, let's look at understand the problem. I'll take for 3 matrices only. 3. They'll only give you one input, n. In this case, n is 3. So this will be the only thing. This will be the only thing they'll give you. Okay, so in this case, let's tell you. Initially, this will be the array of n by n. So it will be 3 by 3 array. So in this case, first things first, you'll be given an array of zeros. All will be zeros. So since it's 3 by 3 of zeros only, so what will happen is, first you will be given two operations to perform. The first operation is, you can take any row. Take this for example, this row or this row or this row, and you can populate that row with a permutation of the first 1 to n numbers, including 1 and n. Okay, which means that, for example, if you take this row, say 0, 0, 0, 0, right? I'm only going to think this is this row, and if you can change one of the operations, you can change this row into either 1, 2, 3, or you can change it 3, 2, 1. You can change it to 1, 3, 2, or any of that, any of the possible combination you want it, you can change it, and that will count as one operation. Okay, operation will be incremented by 1 when you do this. Okay, so this is the thing. Another thing you can do is, you can either change the column to similarly either 1, 2, 3, 3, 2, 1, 1, 3, 2, or any of this possible combinations. You can change it. You can even change it multiple times. For example, if you can change it from this, for example, if it's 0, 0, 0, you can change it to 1, 2, 3, and then you can change it again to 3, 2, 1, then you can change it again to 1, 2, 1. No, not 1, 1 to 3. Yeah, in this case, see, only the permutation of the numbers is possible. You can't change this back to 0, 0, 0 again. That's not possible. Once you change, you can always change it only to the permutation of the numbers. So 1 to n, whatever permutation is possible, you can change it. And same for the row. What they ask you is, first things first, you have to make it such that you have to use these two operations in such a way that this array should have numbers placed in them such that at the end the sum is maximum. So if you add all of these numbers after you place these numbers, in this case if you say for example 1 2 3 1 2 3 1 2 3, if that is the thing, then if you add all of these numbers, what will you get? You'll get 5 6 3 5 6 right, 18. You'll get 18 in this case. So you need to find out the sum of this such that it's maximum. You have to place the numbers in such a way that the sum will be maximum, and with that you have to also show the number of operations that you have done, which means that the output, what they're expecting is, first things first, the sum. What is the sum? The maximum possible sum for this. What are the number of operations you did it? And in this case, there is a restriction on the operations, which is you can only do it 2n times. You can only do 2n operations on this one, and you don't have to minimize this thing. You just said that don't do more than 2n operations. So you don't have to minimize the number of operations you do. You don't have to do it in the least amount of operations. Just have to maximize the sum, and you have to do it in 2n operations. Under 2n operations, equal to also is okay. So first they're expecting this, and the next they'll expect what they expect is for each and every line from now on, for the next OP, I mean the operation number of lines, how many operations are there. You first thing they'll expect is which operation is it. If the operation is for row, then it will be 1. The operation for row is operation 1. Operation for column is operation 2. So if it's first, if you're doing the performing the row operation, you have to mention 1, and if it's column, then 2. And the next one, what they're expecting is which row or column are you performing on. If it's on first, second, third, first, second, third. So whatever column or row it is. So I mean 1 2 3 or 1 2 3, any of the rows or columns. And in this case it's just 1 2 3. And then what is the permutation of the numbers? Are you inserting 1 2 3, or are you inserting 1 3 2, or what is it that you're inserting? You have to print completely. You have to print the entire number, the entire permutation till n elements. In what permutation are you adding it on? So these are the operations you're supposed to do it. You're supposed to print. So this is the output. This OP times you are supposed to print it. Okay. So in this case, see, let's understand one thing. The thing is, you have to make sure that the sum is maximum, right? How will the sum be maximum in this case? Because the sum can become maximum if, see, the more 3's you have, because the permutation will be 1 to 3, right? The more 3's you have, the more your sum will be more, right? We will maximize. If the entire array is filled with ones, take it hypothetically, even though it's not possible. If the entire array is filled with ones, if the entire matrix is filled with ones, then I don't think the sum will be a lot, right? It will just be 9, right? 1 2 3 4 5 6 7 8 9. If the entire array is filled with 3's, it will be really, really, really good, right? That is the maximum possible case. But it's not possible in this case. So imagine these lines like sticks. So first things first, the permutation thing that they mentioned it's a bit to trick you actually. The thing is, you take it 1 2 3. For example, if you populated 1 2 3 1 2 3 1 2 3, if you change these elements, it's not going to change. If you say 1 3 2, the sum is still going to be same. At the end, if you look at it, even at whatever combination you do it won't matter. So the best thing is to just take 1 2 3. 1 2 3 is the best combination. No permutations required. Just print 1 2 3 here, and you can only always take 1 2 3, be it for row or column. Even for column, it's the same 1 2 3. That's it. Okay. So now you'll be given. You have to place this. Imagine this 1 2 3 as a stick, where 3 is the maximum value, right? So imagine this as like a stick with a dark point. If you turn it here, it will become like this. So this is a stick. Okay. You can place this stick in such a way that you have to maximize the number of black points, right? So how will that be? How can you do it? If you're given this way, you can use how many sticks? You can use 2n number of sticks, right? So 2n number of sticks, if you take it like this will be the black value. So if you take for what do you say? If you take it like this, okay. So then now it's 3 by 3, right? So you can place a stick like this, right? You can place one stick like this, Then after that, where else can you place a stick like this? If you think about it, where else can you do it? You can also do another stick here, right? Right, if you do place one here again, if you place another stick here, then you can do it here too. Now if you place another stick vertically, you can place one here too, and this will be the black one. You place one here, you can place one too. Now you might think, if you place one stick by reversing it, you can place one here, right? No. The thing is, if you place 1 2 3 like this, and if you substitute it with 3 again, 3, it will become 3 2 1. So 3 is gone now, it's 1 now. It's not like 3 2 3 you will get. So you can't overlap it on one another. The blacks should be visible. So if you place another stick on top of the stick, then the black one visible. The white one will be overcoming the black one. So in this case, this is the maximum possibility we can get for 3s, right? And if you notice, if you will get, for example, if you take 1 2 3, right? 1 2 3 1 2 3. Here we place it like this. Now if we reverse this thing, we'll get 1 2 3. If you place it again here, 1 2 3, right? But see, now it's everything is fine, everything is good, but we have a 1 here. Now see, if you follow a pattern, it's 3 3 3 everywhere here, but here it's just 2 and here it's 1. Now patterns always follow a pattern, right? So it should be like something like this. So you're supposed to put these in such a way that this sticks way of putting them is okay, but you're supposed to put them another way. And that other way here is, it's just an observation based thing. You place, for example, take this thing, take the grid again, place first one here, okay, you'll get a black here, right? You place another one here with the black facing this way. So okay, nothing will happen. The black is the same at the same point, even though you covered it with the black again. You covered the black with the black, so nothing will happen. So you'll get 1 2. I'll write 3 is a black, so we know that. Now you write another one here again, okay, other stick here, so it will be covered by a black. It will be 1 2, right? And then you place another stick on top of this, so you'll get 1 2 and black. Now place another stick here, it will become 1 2 and another black. It come 1 2 and another black. See, now we have this pattern that we want, the 2s, the 3s and the 1. This is the maximum possible thing. You can't again put another one here. Even though if you want to put one, you can put it like this. So it will come as 3 2 3 2 2 3 1 3 3. Even then the 1 will be here. So even if you change it, no matter what you do, this is the maximum you have squeezed out of this operation. So basically, first what you suppose, if you notice, it will take 2 and, because 1 and 2 3 and 4 and 5 and 6. So for every row and every column we are doing the operation, so it will take 2n. So first things first, 2n is the operation, so we need this and these outputs, right? In this case it's 2n. So for sum is basically, you see, there are odd values, 1 1 3 2s 5 3s, it's like that. So it will just be summation of I from 1 to n, I into 2 of I minus 1. 2 of I minus 1 is the what do you say, iteration for odd numbers. So if I is 1, then it will be 1. If I is 2, it will be 3. If I is 3, it will be 5. So this is an odd number. You'll get an odd number from 1 to n, and this will be the value. So 1 into, so it will be 1 into 2 minus 1 is 1. So 2 into 2 minus 2 is 4 minus 1 is 3. So 3 2s and 5 3s, like that. So this will be a sum. Now for this one, it's just simple. What you'll do is, for each for loop, you'll iterate through the for loop n times, since 2n operations, right? So for each iteration, what you'll print is, you'll first print 1 because first we are performing the row operation, right? From last, we'll perform from last, and I will start from n and I will end at 0, at 1, and I will decrement. Okay, so for I in n, I is less than or equals to 1 and I minus minus, you'll print n. First you'll print 1, which is the type of operation. Next you'll print n, since here you put it on the last row first, so what row or column you're printing it at, and next you'll print just 1 2 3 again. Okay, the perm till from 1 to 3 till n, whatever the values. Then you will print, in this case not n, it will be I. Then you'll print 2 and I, and similarly 1 2 3 and n, and we'll keep reiterating this thing. So what we'll get is, since I will keep decrementing, so first we'll get this and this and this. So you'll get that automatically if you print this thing. So the only thing you're supposed to print is first this, then you're supposed to print this. Then for loop from I to n, I is equals to 1, I minus minus, you're supposed to print first is first operation, I 2, and the permutation, in this case not the permutation, the order or the numbers, just print 1 to n, that's it. Don't mind this. And for 2, what you're supposed to do is second operation. So say you're doing for the column 1, same, the column will also be I only, and same again. You keep doing this thing, you'll get the answer. That is the only thing. So I was only able to solve till C. So when I'm able to solve till D, then I'll start uploading for D2. So yeah, that's it. Thank you.